So I've pulled this up, the Ohm's law a little bit, just because we'll deal with it some and help you understand what current draw is what the pedal needs as far as current goes. Okay, so current is amperage. That's how we measure amperage. Voltage is pressure. We measure voltage by pressure. So the voltage is pushing the amperage through whatever electrical component. And ohms is going to resist it. We're not going to really deal with ohms in this topic, but it just for the sake, since it's up on the screen, we'll just say ohms resists. Okay, it's like a dam. It's almost like you put your thumb over a water hose to compress the water down to get it to spray out, right? So certain pedals require certain amount of voltage, and here is the Chalk's chocolate, and on this we have the first outlet of it is going to be 4 to 15 volts DC at 100 milliamps. So very low draw, and that can come in really nice when you're using a fuzz or an overdrive, where you can kind of get it to sag a little bit. Outlet 2 through 4 is 9 volt DC at 100 milliamps. Outlets 5 is 18 or 24 volt DC, 100 milliamps. Outlet 6 through 7 is 9 or 12 volt DC at 200 milliamps. Outlet 8 through 9 is 9 or 12 volt DC at 400 milliamps. Outlet 10 through 11 is 9 and 12 or 15 volt DC at 400 milliamps. Outlet 12 through 13 is 9, 12 or 15 volt DC, 600 milliamps. Then outlet 14 is 9 or 12 volt AC, so not alternating current, not direct current, 800 milliamps. And outlet 15 through 16 is 9, 12 or 16 volt AC at 800 milliamps. Now that's really important to know the difference between DC and AC. You will fry a pedal. If it requires DC, you will fry a pedal, like hands down. And now here is the Big Sky. The Big Sky is a 9 volt DC 300 milliamp. So what we could do with this pedal is we could plug this into either the 8 or 9 volt or the outlet 8 through 9 at 9 volts, 400 milliamp. Now you have to really be careful, and I'm gonna explain that. If you put that pedal at 12 volt DC unknowingly, you will fry it. So you really need to make sure that you select on the sliders what voltage goes to that pedal or to that outlet on the power supply unit itself. So over here on the right we have a bunch of little sliders. Those sliders are going to determine what power goes where to what pedal. Okay, and that is super important when dealing with these. And I'm going to explain a little bit more on my board, but here's the board we're currently dealing with. And I put this up here as kind of a reference. So we have a few pedals. None of these pedals are drawing over 300 milliamp. None of them. None of them are drawing over 300 milliamps. So we're pretty safe with sticking between 100 to 200 milliamp. And like I said, it doesn't matter about milliamps as far as like blowing a pedal up. So as long as you have the only time that a pedal gets hurt from milliamps is if there's not enough. And that's usually, and I'm going to say usually, but I've done it where I've sagged power before for like fuzzes. I've never had any issues. Sagging power on digital pedals, you can run into a lot of problems because that power is gonna that amp is gonna that pedal is gonna create a noise floor to where it's not gonna have enough amperage going to it to actually power it. So that's something that we really want to keep in mind whenever we're putting together this board. So here's the layout that I've created, starting with tuner, wah, compressor, octave, and then the drives going into a phaser, a delay, and a reverb. And this is not uncommon to see this sort of layout. And then what you can do is leave it like this, and then as you add more pedals, you can just add in more as you go. So if you keep it like this as a nice, neat, clean kind of slate, you have way more area to work with in case you want to add more pedals or take pedals away. All right, and here I'm going to talk a little bit about the layout of the board that I created, and this is what I used to create this. Now this is what was sent to me based off of it, and these are the patch cables I recommend using. These EBSs are awesome. I've used some of the Ernie balls, they're not too bad. And then of course, just for reference, I found some of these online and decided to throw them up there. So with patch cables, I'm pretty picky. The EBS ones are excellent. They are a little expensive, but they're absolutely fantastic. And I always think of like my cables and my patch cables, I want to have the less amount of impedance. I want to get as much signal through as I can. So I try to keep my cables shorter. If I have to cut cables, I make sure that they're soldered with gasless gap type patch cables. That is me. Not everybody does, not everybody thinks in the same lines I do. But one of the things you can do to kind of sort of alleviate having to solder patch cables and all that is they sell different length patch cables at different qualities. Have a couple of extra long ones for whenever you have to make a turn or something like that on the board of going to another pedal or whatever. But try to keep them as short as possible. That is the biggest thing. And then keeping, your guitar cable at a decent length from your pedal board, because even though a lot of us we're just hobbyists, right? But if we do gig out, knowing that you're going to have that extra 30-foot cable or 25-foot cable going back to the amplifier, that's a lot of impedance. That's a lot of tone loss there. So keeping your board nice, neat, and tidy, and having the cables be as short as possible, with the least amount of runs in it as you can, that's going to help a lot for tone. Along with the tie downs, these black zip tie mounts are amazing. One thing about it too is when you do your cable runs, and I'll explain more, but you don't want to have your cables run in parallel with your power cables. So your guitar cables, your patch cables, don't run in parallel. You want them to X over the top of each other, and that'll also keep down the noise floor as well. Okay, and the next thing we'll talk about is hook and loop, or also known as Velcro. I use the 3M Velcro. It seems to be better than what comes with normal pedal boards. I like it. I always put the fuzzy side to the board. I think that it's that you need to have a coming to Jesus moment if you do it the other way. But yeah, I prefer Velcro. Now there is another tool out there that you can use, and it's kind of expensive. I only found it on one site. I'm sure that there's more, and I know that some pedal board companies or people that make pedal boards or whatever will offer the 3M dual lock, but it is rather expensive if you buy a whole roll of it. The cheapest I found for an entire roll, which is it says 1x15, price $245 each, so buying a whole roll of it just doesn't make sense. But if you want your pedals never to come up, 3M dual lock is it. But it is expensive, but it's what, like if you're gigging, okay, for the average person, average bedroom player, just go with Velcro. Okay, and now we're going to talk a little bit about the pedal board. So I have a fuzz and an overdrive. Okay, the fuzz goes before the overdrive. I don't run a compressor. I don't run a boost with this board. I don't need it. I'm not going to be boosting a 25 watt amp in my bedroom. I would never get it to the verge of breakup anyway. So right here I have a tuner, and yes, it's a tuner, whatever. But the thing that I want to point out is that it is not true bypass. Okay, no tuner is. Right, and it's going into the fish pedal. The fish pedal is true bypass, which is leading into the Lucky Cat delay, which is not true bypass, which is going to the Source Audio Venturous reverb pedal, which is also not true bypass. Okay, now if you look behind there, I have you can see where I've routed those cables. Those cables, those are the things that I was talking about that you can put down. They're 3M, they're cheap, you can buy them. Really good. Now, if you look at the top of this power supply, you'll see those white letters and numbers. Those mean things. Those red dip switches right there, those are what allows me to select the power in between each one. Okay, so you don't want to do that unless you have to. At least I don't. So like with the red pedal and the gold pedal here, I keep coming back to them, but with the red pedal and the gold pedal, the thing about it is that I think I can run the gold pedal at like 12 volts or whatever. I can run it hotter than what it is. I can't remember off the top of my head. I'd have to read about it. I don't run any of my pedals any hotter than 9 volts. Here we are with the pedal board, and I'm going to kick off the tuner. Now we're going to go ahead and throw in a little bit of reverb. Now we have it to where we have the overdrive. I'm going to kick the overdrive off, and I'll engage the fuzz, and we'll see what it sounds like from there. Now we'll go ahead and engage the delay pedal and give it a whirl.
Source audio of interest, and I'm playing it kind of mellow, feeling a mellow mood, so we'll play a little mellow here. So anyways, you're hearing some of the sounds that it has. Can't play it real loud, it kind of got laid on me, so just trying to keep it as mellow as possible here. But yeah, I'm really a huge fan of this board, and I absolutely loved it. As you can tell, there's not much noise floor to it. I've kind of kept it pretty well. That was like the goal, was to keep it low noise floor and just have a very simple board and just keep it as simple as I could, but still having some of my favorite sounds out of it. So anyways, there it is.